This is a homework help video for Advanced Algebra, Lesson 4-7. We're going to look at 4 problems. The first being number 10. It asks if two matrices are inverses of each other. Well, to prove or disprove if they are or are not inverses, you have to multiply two matrices together. That means do the row times column multiplication idea that we've done in the past. So for number 10, if I multiply rows times columns, row 1 times column 1, I'll have 0 times -1 plus 1 times 1. Row 1, column 2, I'd have 0 times 1 plus 1 times 0. I go through and I do my next set. Row 2 times column 1, 1 times -1, plus 1 times 1, and row 2, column 2. 1 times 1 plus 1 times 0. I do my multiplication and my addition. Row 1, column 1 then will be a total of 1. Row 1, column 2, 0. Row 2, column 1, 0. Row 2, column 2, 1. If I look at my final matrix from that multiplication, I see that it's 1, 0, 0, 1. That is the identity matrix. So is number 10 an inverse? Yes, it is. If you multiply two matrices together and you get a main diagonal of 1s, and every other element is a 0, then they are inverses of each other. That 1, 0, 0, 1 matrix is the identity matrix for a 2 by 2. Next problem we're going to look at is number 12. Same type of problem. Are these two matrices inverses of each other? So we again multiply to see if their product is the identity matrix. Multiply one matrix times the other. I will again do the row times column idea. Row 1, column 1, 6 times 1 plus 2 times -5 halves. Row 1, column 2, 6 times 1 plus 2 times -3. Row 2, column 1, 5 times 1 plus 2 times -5 halves, and row 2, column 2, 5 times 1 plus 2 times -3. I will do my multiplication and my addition to find my answer matrix here. Row 1, column 1, total of 1. Row 1, column 2, 0. Row 2, column 1, 0. Row 2, column 2, -1. That's all from my multiplying and adding of those specific elements. And I take a look at my answer matrix. Is it the identity matrix? No. This is not an inverse. Why? Because of that right there. You cannot have a -1 anywhere in your answer matrix if these two original matrices in the problem are inverses. It can only be 1s on the main diagonal and every other element 0. Number 26 asks you to find the inverse. That's what the little -1 means, is the inverse of that matrix. So what I have down below is the process that you follow or the pattern you follow in order to be able to find the inverse. Right here, to start, if I have some 2 by 2 matrix with these elements, A, B, C, D, the inverse of that 2 by 2 matrix is equal to 1 over the determinant, DET, determinant. And then you can see how the elements have to be rearranged. A and D, the two elements on the main diagonal, switch spots. B and C, the other diagonal, they're the opposites. That's why it says -B, or the opposite of B, opposite of C. Those numbers stay in the same position, just take the opposite of them. So if I take a look at the 2 by 2 matrix number 26, first thing I'm going to figure out is my determinant. In order to be able to find my determinant, I take A times D, if you're using that idea, or the main diagonal of 4 times 7, and I subtract the product of my other diagonal, or C times B, which in this case is 2 times negative 3. I end up with 28 minus negative 6, which is a total of 34. So for my inverse for number 26, it will be 1 over 34, because 34 is my determinant. It's the inverse or the reciprocal of the determinant. I take that 1/34th, and I will again now look at what do I do with A and D from my original to my inverse. I flip those two numbers around. So instead of the 4 being in row 1, column 1, I'm going to put the 7 there. Instead of the 7 being in row 2, column 2, it's now in row 1, column 1. The 4 changes places with the 7. And then for my other two numbers, my other diagonal, I take the opposite. The opposite of B. Well, that's the negative 3. I take the opposite of negative 3. So I'm writing a positive 3 there. And I do the same thing for row 2, column 1, which is the 2. What's the opposite of 2? Negative 2. So I now have my inverse matrix for the problem number 26. Now your teacher may ask you to distribute that 1/34th and just get a 2 by 2 matrix instead of a scalar multiplication times a matrix. That's going to be up to your individual instructor. I look at 28, same problem. What's the inverse? Same type of problem as 26. What's the inverse? Well, I can go back to the previous slide if I need to look at that formula, but it starts by finding the determinant. Okay, my determinant is I take the product of the main diagonal, negative 4 times negative 9, and I subtract the product of my other diagonal, 6 times 6. Negative 4 times negative 6 is 36. 6 times 6, also 36. So my determinant is equal to 0. Well, right there I can stop. And I can write that no inverse exists. Why? If I go back to that previous slide, when I find the inverse, it's 1 over the determinant, which means in this instance, I would have 1 over 0. You can't divide by 0. That is undefined. Hence, there is no inverse for this particular 2 by 2 matrix.